screen. Okay. So, okay, just to do some recap with you guys. Last week we have looked into analytic methods, half of the chapter for part 1. Okay, we have looked into categories of analytic methods and also methods for data analytics, which is CRISDM. Okay, hopefully you guys still can remember the CRISDM. And then for today, we are going to continue looking at the popular analytic methods and also how to choose the right analytic methods based on your case study. And we are going to look also at chapter 3 part 2, which is a confusion matrix. Okay, so insyaAllah kita sempat habis benda ni. Okay, so last 2 weeks kita habis dekat sini. So today I'm going to continue this analytics method. So if you can see here, there are 6 analytics method that I think the common task that people always do now. Okay, when they have the data, they will do classification or regression, similarity matching, clustering, co-occurrence grouping, and also profiling. And some of this method you have learned in data mining and also in machine learning. So kalau you ingat balik the clustering, you belajar dekat dua-dua kan, machine learning ada, data mining pun ada. Same goes for classification and also regression. Cuma macam regression tu mungkin tak ada specific algorithms yang macam you all kena belajar dalam statistics lah, all the ARIMA apa semua tu tak ada. Okay, but similarity matching pun I believe you have learned this in data mining. Co-occurrence grouping pun, cuma profiling je tak ada. But usually profiling you can use clustering, okay, to do it. So we have 6 tasks, and using this this case study, we are going to look at how can we perform each of the tasks. Okay, maknanya satu case study tu kita boleh guna untuk banyak task, analytic task. Okay, so the case study is about a mega telco company. Okay, a short description about this mega telco. So this company is a telecommunication company. So it has major problem with customer retention. So it's about 20% of cell customer are leaving soon. Okay, after their contract expired lah. And they said that it is difficult to acquire the new customers. So they tried to do some survey ataupun to give some offers lah to the customers, and they would like to know what are the insights that they can get from from all the tasks yang ada tadi lah, yang kita dah shortlist tadi tu, yang ada 6 tu kan. So the cell phone market has been saturated. And then kalau tengok kat sini, customer switching from one company to another is called churn customer. So yang mana you all tengok dekat customer data, okay, that we use rapid yang kita guna dalam ETL process for what? ETL proses rapid miner hari tu kan, yang ada kita akan tentukan sama ada churn atau loyal tu. So boleh diguna pakai untuk ni lah. Okay, itu contoh dia. But this is the case study. Let's look at how can we do this 6 methods in solving the problems. So kita tengok the first one, classification. So the goal of classification is to predict in which class the individual or the customer belongs to. Okay, so the question that you should ask is, among all the customers of Mega Telco, okay, which are likely to respond to a given offer? Let's say they tried to give some offers to the customers to make sure that the customer are not leaving them kan, tak terminate dia punya services. So they are trying to give some offers based on the customers punya preferences lah. So here the individual is a customer, okay, and the classes, let's say, will respond or will not respond to the offer. Kan macam I'm sure you all have have an experience receiving a calls from call center, tanya you nak tak offer sekian. So that kind of promotion lah, contoh dia offers yang dia orang nak bagi kan. So adakah that customer will respond to that offer, will receive that offer, ataupun dia tak respond dan refuse lah to take the offer kan. So the classification task here is you need to use the data mining models to predict which class an individual belongs to. Okay, we have to do a classification, yes atau no. Okay, yes if the customer willing to respond to the offer, and no is if the customer is not willing to offer to respond to the offer. Okay, that one is classification, or you can also do class probability estimation, where instead of looking at yes or no, you can assign ataupun you boleh buat prediction based on the probability. Okay, so you akan come out with a score lah, with a score value. Macam tadi kan yes, no kan, but now dia ada macam how many percent the customer will respond to the offer and how many percent the customer will not respond to the offer. So we have another dia punya infographic dia lah. Okay, let's say we have a bunch of customers here and we have an offer. So let's say kita nak pakai class probability tadi tu. So let's say 80% of the customers will respond and the other 5% will not respond. Okay, so you boleh tengok lah, and you can also calculate the probability for every customer. Okay, that one is classification. It's a normal task lah. Macam you dah belajar, you dah biasa dah tengok dalam in your data mining, in machine learning. So it's a very, I would say, simple task. They're very straightforward kan. You nak kelas-kelaskan dia. And then we have another task, which is regression. So the goal for regression is to predict or estimate for every individual that they have, for every customers. Okay, they try to predict the numerical value of some variable for that variable. Maknanya apa benda, dia punya first variable is the objective. So they try to predict the other variables that contribute to you punya objective tu lah, to the another variable tu. So the question here is how much will a given customer use the service? Okay, kita nak predict guna regression. So here the task will be predict the service usage property for a particular individual, typically by looking at other similar individuals in the population and their historical usage. Okay, so dia ada seorang customer and they tried to look at the similar individual based on the usage. Kalau kata we know that in telco apa je yang ada, calls, kalau pakai SMS and then data kan. So offers tu will be given based on the usage. So kita boleh tengok lah, kalau kata orang ni mungkin kalau dia pakai calls banyak, mungkin dia tak pakai data sebanyak yang orang the other individual yang memang depends on the data kan. Kalau you tengok package pun Maxis, Celcom pun dia started to have that kind of packages. Maknanya dia akan tanya the sales salesperson tu, dia akan tanya you pakai, maknanya your usage tu ke mana? Is it data, you suka search surfing ke, ataupun you banyak calls? So the product, the offer tu akan diberi ikut kesesuaian tu. Okay, so you can use the regression to predict the service service usage lah, untuk tengok ataupun untuk to check the similarity among population tu. Okay. So the next one is similarity matching. Sama juga konsep dia macam regression tadi. Dia macam duduk tengah-tengah tau. It can be classification, it can be regression. Tapi dia tak adalah macam solely on classification atau regression. dia macam ni, macam kalau you buat classification, you buat regression, betul you buat classification, tapi kita akan tengok macam okay, ini similar tak dengan orang ni, orang ni similar tak dengan orang tu. Okay, untuk identify, untuk mudah nanti kalau kata nak buat profiling ke whatsoever, boleh lah. Okay, so the goal for this similarity matching is to identify similar individuals based on the data known about them. So the company need to store the data about their customers. So based on the data tu, dia akan tengoklah similarity matching. Kalau kata classification, regression tu, we have a specific machine learning methods kan. So kalau similarity matching ni mungkin you akan tengok macam based on the profiles, maknanya after doing the profiling, guna classification, guna regression, guna clustering tu, you can form this similarity matching. And most of the popular methods for making product recommendation, okay, is this one lah. Sebab macam kita nak tengok kan, kalau kata orang ni that have the similar characteristics ataupun similar profiles with the new customer ni, dia akan macam okay, kalau orang ni suka ini, meaning that the new customer most probably akan suka juga those products. Okay, because they have the similar characteristics. Okay. And the next task is a clustering. Ini pun sama juga. You have learned this clustering method in data mining and also machine learning kan. So the purpose of clustering is to group the customers into few groups ataupun few clusters using their behavior lah, the similarity features that they have. So kalau you tengok dekat situ, okay, the image here. Okay, we have a group of customers. So the blue group, they text occasionally, and then the other group, okay, mungkin dia akan receive calls only or seldom calls nor text, and then the other group text frequently. Another group is need intensive data plan, and the last group calls for long hours. So each of these clusters, dia akan ada target plan dia lah. So kalau kata for this one kan, calls for long hours. So what are the plans can be offered to this group of customers? Kalau pakai data plan, okay, apa? So the goal for clustering is to group individuals in a population together by their similarity. So you dah belajar dah how to calculate the similarity everything. For example, kalau you pakai k-means, so it will look at the mean distance kan, between the centroid and also dia punya neighbours. And then you can also use the other clustering methods. Contoh kalau pakai cohonent untuk buat clustering, you need to calculate the Euclidean distance, the the distance between one data to another data. Okay, but this one is not driven by any specific purpose lah. Because we know clustering kita tak ada target kan. So kita macam you have the data and then you just perform the clustering to see what kind of insight that you can get from the data. Okay, what kind of info. It doesn't mean that ini sahaja, for the service sahaja, maybe you can get other data. Okay, other info. So the question here that you can ask is, do our customer form natural groups or segments? Sebab kita tak tahu kan, bila dia form a groups tu, you need to investigate, you need to analyse each group represent apa. Okay, macam contoh yang ni mungkin dari segi usage, but maybe you have another cluster ataupun another behaviour instead of usage, apa lagi? Maybe a group of mungkin ada devices ke, mungkin ada a group of people, maknanya kita tahu dah macam okay, kalau kata calls for long hours ni mungkin average-nya 40 and above. So dia punya range of income berapa. So you can get so many things based on the clustering results. And it is very useful in preliminary domain exploration. Okay, we know that the clustering always being used during the data exploration. Maknanya you nak faham tentang data because we don't have any idea about the data. For example, you tak tahu apa-apa kan, you just receive a data, you can do clustering to look into what kind of info yang you boleh dapat. So you boleh do exploration lah, tengok satu. Okay, kat sini kata apa, which natural groups would later suggest other data mining tasks or approaches. Okay, kita ada banyak kan clustering using data mining, either AI ke atau statistical punya method. So you can choose. Okay, the most common clustering methods that they use in data analytics is k-means lah, because itu paling mudah. Kalau kohonan tu dia macam banyak sikit kan, banyak nak especially when you want to you cannot define the number of clusters. Kalau macam K tu kita boleh define the number of clusters. Maybe dia jadi macam semi supervised, where you have an idea. Let's say like kata, okay, I nak tengok lah the group of people yang pakai usage. So how many services yang you ada. Let's say you have 5, so you can set the K equals to 5 sebab you nak tengok. Itu macam predefined value. Tapi if you use kohonan, we know that kohonan cannot give you cannot specify ataupun you cannot initialize any number of clusters to be formed by kohonan. So that's why k-means tu macam the most common clustering methods lah. Tapi it's not limited to k-means. We have lots of k-means clustering methods, and I'm sure you have learned that in data mining. Hopefully you ingat lagi lah. And another task is co-occurrence grouping. Okay, this is similar to the things that you have learned in data mining lagi. Okay, the frequent item set, association rule discovery, market basket analysis. Ini semua saya rasa I don't need to explain lah sebab you dah belajar benda tu kan. Ada specific chapter in data mining. And the goal for co-occurrence grouping is to find the association between individuals based on the transactions involving them. So dia akan tengok per customers. So customers A dengan B ada association tak? So based on what? Based on the whatever transaction yang dia buat lah, whatever activities yang dia ada. Okay, kalau dalam case telco ni transaction lah, tapi kalau other cases maybe other activities. So the question is, what items are commonly purchased together? So you can assume that if A purchase product or service A, okay, if B having the same characteristics with A, meaning that B pun akan purchase product ataupun service A juga, sama macam yang individu A buat tadi tu. Okay, so identify similarity of objects based on their appearing together in transaction. For example, people who bought X also will bought Y. Okay, this is the example. Okay, kalau kat sini, okay, hungry people who bought pizza also bought noodles. Therefore, always offer noodles to someone who bought pizza. Okay, dia buat generalization lah based on the sample cases. So dia generalizekan siapa yang beli pizza akan beli combo punya noodles. So akan adalah some offers. Kalau kata beli pizza, okay, katakan noodles half price. Contoh. Okay, next one is profiling. This one has become a very famous lah. Profiling, lepas tu buat segmentation, everything kan. Orang dah start looking into this area, these methods. So it also known as a behavior description. So the goal of profiling is to characterize, okay, the typical behavior of the customers, of a group of people lah, yang let's say kalau kata dalam company untuk business tu, the customer ataupun the employee pun boleh juga buat profiling. Patients, okay, you can have that Maknanya you nak characterize tu based on apa. Kalau patient mungkin based on the medicine, based on types of comorbidity yang dia ada, based on the treatment, everything. But for the customer maybe because of we can do the this profiling based on the money spent in buying their products ataupun the services. So you boleh buat semua-semua benda tu. And when you have the profile, the customer profile, so it will macam mudah lah for the company untuk buat targeted punya marketing. And then the question that you can ask is, what is the typical cell phone usage of this customer segment? So kita balik pada telco company tadi. Okay, you can do profiling. Let's say you nak tengok in terms of cell phone usage. So you boleh buat profiles. You have 10, for example, you have 10 individuals, 1 sampai 10, so each individual macam mana. Okay, profile dia punya call usage, dia punya internet usage. So you akan ada setiap satu tu profile, and then you can group, you can segmentize those 10 customers into few segments based on their punya profiles. Okay, so profiling task here require a complex description of nights and weekend airtime averages, internet usage, roaming charges, text minutes, and etc. Okay, so banyak benda sebenarnya nak buat profiling ni. Dia bukan sekadar macam, okay, tengok data, okay lah, that's it. Kita boleh kata, okay, ini group of customer macam ni. Tak, dia bukan boleh tengok pada satu aspek je. You need to look at all aspects. Okay, untuk make sure that your profiling tu is overall punya ni lah, dia akan cover the whole aspect of the business. So for example here, we have Jane is a student. So this is the usage of Jane's profile recorded by the telecom company. Let's say for January, February, March, dia banyak guna on WhatsApp, on SMS, on the calls. Okay, but suddenly dia banyak on surfing on April. So mungkin dia macam dia tak mismatch lah. Dia mismatch with the profiles yang sebelum ni dia banyak on messaging untuk calls kan, tiba-tiba nak internet je, so dia akan bagi alert lah. Mungkin, okay, dia bukan kata macam 100% betul, tapi mungkin, maybe mungkin ada fraud ke apa benda, adalah tak mismatch dengan dia punya profile. So maybe telco company tu boleh verify dengan the customer balik. Okay. And which analytic methods? Okay, we have learned the 6 types of analytic methods. So which one which one is suitable for the business problem, for the objective? So that one is actually very tricky, very complicated, okay, because you need to understand the business problems, you need to really understand about the objective, try to figure out how can you propose a solution to solve the problem. So nak identify process, the beginning part, okay, the first few steps of Chris DM tu, business understanding, data understanding tu, the most crucial steps ataupun the most crucial phases dekat dalam development bila melibatkan analytics. Because kalau salah dekat depan, dia akan carry sampai belakang. Macam kalau software development, sama jugalah, kalau kata user requirementnya tak betul-betul solid, tak betul-betul complete, okay, then you akan dapat satu sistem yang macam mungkin at the end nanti user kata, no, I tak nak macam ni, I nak macam ni. So sama juga konsep dia dekat sini. So one of the way to identify the analytic method is by identifying if the business problem requires a supervised or unsupervised. So itu mudah. So you have the target ke tidak. If you have the target, meaning that it will falls under supervised learning. Maybe you can do classification, maybe you can do regression. Okay, and profiling also. Tapi profiling tu lebih lebih kepada task lah. Nak buat profiling pakai apa tu, tengok. You boleh tengok, patah balik ke sini. Okay, the type of whether it has a target or not. So kalau target, supervise. Kalau you don't have any target, macam you nak tengok the behavior of the customer based on the data, then you can choose the unsupervised data mining method. Okay, we have lots of supervised and unsupervised. Saya rasa you dah tahu dah benda tu, so tak payahlah saya nak kena list dekat sini. And let's say we have two session. Okay, ni dia punya dia punya two condition. So one, do our customer naturally fall into different groups? Okay, you dah ada target belum kat situ? Okay, do you have a group? Macam tadi kita kata kita nak tengok whether the group whether the customer will respond or will not respond to the offer. So kalau lah kata tak ada, you kata macam tak tahulah nak letak apa, berapa groups, and then tak tahu apa groups yang kita nak groupkan. Then so you can use clustering, you can use profiling, you can use co-occurrence grouping. Sebab you akan tengok, you can try untuk investigate apa lagi. Okay, what are the info, what are the insights that you can get from the data? Mungkin sikit, mungkin banyak. Kalau kata you pandai investigate, you pandai analyze, then you will get lots of info. So the other one, okay, can we find group of customers who have particularly high likelihood of cancelling their service soon after their contract expired? So here, if you can see, kita boleh nampak dah ada target sebenarnya dekat question tu. Okay, whether the customer will cancel the service or not cancelling. Okay, ataupun dia akan stay with the company. So kalau kat situ kita ada target lah, yes atau no. Okay, therefore we can use classification or regression. Okay, and based on the results too, you can also perform based on the data, you can also perform similarity matching lah untuk tengok macam, let's say you have a new customers ataupun you have existing customer but new cases, so you can check. Okay, kalau kata customer ni existing, so you boleh tengok profile customer lain yang mana similar to that customer, try to do similarity matching, tengok apa benda yang you boleh buat supaya dia remain dengan ataupun dia tak churn lah. Okay, dia tak leave the company. And kat sini pun sama jugalah untuk classification and regression. I think you already know how to differentiate the condition, where to use classification and where to use the regression. So kalau you ada a continuous numbers yang you nak kena predict, so itu adalah, it falls under regression kan, kalau you ada macam range of numbers. Tapi kalau you have a solid distinct class A, B, C, class A, class B, 1, 0, then you need to use classification. Okay. And last one of this part 1, okay, you need to know, inilah untuk classification or regression ni, dia ada 3 questions here. So jom kita tengok untuk the first, second and third ni, you nak pakai classification or regression. The first one, will customer purchase service S1 if given incentive X1? S1 if given incentive X. So this one classification ke regression? You rasa-rasa apa? For number 1, number 2 or number
regression?
Number 1, will the customer purchase service? Will this customer purchase service if given incentive X? Regression. Kenapa you cakap regression?
It doesn't seem like classification.
Kan dia nampak macam classification because you have to target. Betul tak? Sebab customer purchase service X S1 if given incentive X. So it's either yes atau no. Ke ada
Oh, okay.
siapa-siapa
Kalau
yang
macam tu,
ada?
then okay lah. Kalau macam tu, then classification lah.
Kalau you kata regression tadi, kenapa?
Tak, because dia macam process of elimination lah. Mungkin bukan classification, jadi dia ada answer is regression lah.
Okay. So second one, which service package S1, S2 or now will a customer likely purchase if given incentive X? Regression ke classification? Which one? Classification kot. Classification. Okay, cuba you tengok soalan tu. Will a customer likely purchase? So, lebih kepada regression. You fahamkan, cuba you fahamkan soalan tu betul-betul. Dia punya words dia soalan tu lebih kurang je macam soalan nombor 1. But nombor 1 tu memang kita tahu dah. Dia macam distinct class. Yes atau no. Tapi yang second one tu dia ada likely. The word likely tu you bayangkan kalau kata you nak buat prediction, you have a line. Likely tu maknanya dia approaching the line. Kan? You akan ada macam, okay lah ni berapa persen dia akan purchase. Tak tahulah. That one is my opinion. You rasa macam mana? You all rasa? Classification. Rasa betul juga apa yang Medan cakap. Tak nak lah ya je. Korang cepat. Agi pula sikit. Alah petang-petang ni kan saya tahu petang-petang dengan nak hujan ni kan. Semua dah lemau dah. You all ada kelas pagi tadi?
Ada test tadi.
Oh, ada test. Okay, faham. Okay, number 3. How much will this customer use this service? How much? Mungkin. Classification kan regression?
This sounds like regression this time.
Okay, so you need to look at the words in dalam sentence tu. Tapi dalam exam, I rasa kita tak adalah tanya this kind of question. Kita macam terus je. Macam, kalau kata you need to perform classification lah. Okay, ni macam nak bagi tahu kat you, okay, these are things yang macam based on the objective. Kan, ini objektif lah ni, you nak tengok apa. Okay, so based on that, what kind of methods yang you boleh perform. Okay, habis chapter 3 part 1. So can we move to chapter 3 part 2? Ini pun you dah biasa dah. You dah belajar dah benda ni sebenarnya dekat dalam data mining dengan machine learning. Okay. Oh, but before that, do you have any question for part 1? The methods? Saya rasa tak ada masalah kot. Saya rasa you all tak ada masalah sebab you all dah ada. Okay, good. Sebab you all dah ada. You all dah belajar dah dalam 2 classes tu kan, data mining, dalam machine learning. So dia sekadar benda ni macam refresh balik lah. Okay, so for part 2, we are going to look at the type of evaluation metrics and how to evaluate the model. So basically we use confusion matrix. Kat sini you all akan kita refresh balik. Saya tahu benda ni ada dalam syllabus data mining, ada sikit dalam syllabus machine learning. How to calculate accuracy, precision, recall, specificity, sensitivity, semua tu kan. Okay, so let's look at the evaluation matrix. This evaluation matrix is used to, okay, it's used to measure the quality of your model. So it doesn't matter if you use statistics ke ataupun you use the machine learning AI model, you kena guna pakai evaluation matrix to measure how effective your model is. Okay, the quality. So untuk tentukan kualiti tu, use ni kena tentukan. That's why for macam contoh, ini lari sikit for FYP, bila you nak propose contoh, you nak kata nak pakai deep learning lah Madam, nak pakai CNN. So what are the performance measure atau evaluation measure that can be used to evaluate your CNN models? Okay, and this is a core part, okay, when you develop a model, because once you develop a model, we would like to know the effectiveness of your model in solving the problem. Okay, azan. Kita berhenti sekejap. Okay, let's continue. So, apa tadi evaluation. Okay, is a core part. Okay, this is very important. So, what kind of evaluation metrics or performance evaluation that you can use for to evaluate your models? Bergantunglah what kind of models that you use. Okay, so if for classification, you can use accuracy, you can use recall, precision, F1 score, and then you can also look into the ROC curve, tengok AUC values, everything. But for clustering, okay, this is more on statistics lah. Kalau you buat clustering tu, kita boleh tengok SSE using the elbow method. Okay, tentukan macam contoh K-means kan. In order for us to identify the best K for our K-means, you boleh pakai elbow method combined with silhouette coefficient. Sebab macam you have the elbow method, tapi silhouette coefficient tu can help to justify the elbow methods punya results lah. And we have the Duns index too for clustering. Okay, so nak pilih ni lah untuk clustering tu usually kita we know that clustering kan macam susah sikit kita nak evaluate, kita lebih kepada classification. Kalau clustering tak banyak sangat lah, maknanya when you have the results, you tengok dia punya elbow methods, you tengok silhouette coefficient, and then we try to analyse every clusters, every segment that you have. Tapi kalau classification, this is very important because of what? Kalau kata tak ada accuracy rendah ataupun slightly low, but precisionnya tinggi, dia punya specificity, sensitivity dia tinggi. So adakah you akan ambil model tu atau tidak? So those are the things yang kita nak tengok. Okay, so how can we measure the accuracy or is there any other metrics to consider for this evaluation metrics? Sebenarnya banyak. Okay, banyak kalau you tengok mathematics, statistics, dia ada lots of evaluation methods. But the one yang I list tadi tu are the most frequent ataupun the most common evaluation metrics that people always use to evaluate the machine learning classification models and also the clustering. Okay, and then you can also use test data of class label tuples instead of training set when assessing accuracy. Of course lah, sebab training data set is used for training process kan, to train our model. So kita tak boleh guna training data set, kita kena pakai a new set, a test data set that haven't been set by the model. And the methods for estimating the classifier's accuracy, you can use a whole out method. Okay, you can use the cross validation ataupun bootstrap. Yang selalu you all guna pakai whole out method lah. You pecah jadi training and testing, and then you akan train pakai training data set, and then you akan test pakai testing. Ataupun you can also use cross validation. You dah belajar dah cross validation dalam data mining dulu macam mana, ada k-fold kan, berapa k you nak kena pecahkan dia, and each of the k tu akan jadi training, akan jadi testing set. Dia both methods ni dia ada pro and cons dia and when to use it. Okay, saya ingatkan balik, jangan pakai dua-dua method ni dalam satu proses. You need to choose. Dulu ada case, if I'm mistaken, saya dah cerita benda ni kan. Ada case students yang dia pakai dua-dua. Dia start dengan whole out method, dia pecahkan, lepas tu dalam whole out method dekat dalam training tu dia pakai pula CV. Pun saya tak faham kenapa dia buat macam tu. I don't know, but wallahu alam kan. And comparing classifiers, you boleh pakai confidence intervals, cost benefit analysis or the ROC curve. Usually students ataupun machine learning engineers apa semua tu, bila dia nak compare models, dia akan tengok ROC curve lah. Sebab itu mudah kan, when you come out with the ROC, kalau kita buat pakai Python tu memang boleh code untuk generate the ROC curve, and then you can see which model perform better from there. Okay, so to generate all the accuracy, precision, recall, specificity, everything too, you need to use the confusion matrix. So whenever you have a classification, you need to come up with the confusion matrix. So tengoklah, kalau you ada 2 class mungkin mudah, tapi if you have 3 classes, macam mana you nak develop a confusion matrix for 3 class. Dan tengok juga the suitability of multi-class. Kalau kata 3 classes tu tahan lagi, tapi if you have multi-class yang macam contoh sampai 10 classes, does the confusion matrix suitable to evaluate your model? Mungkin you kena pakai F1 score, you kena pakai benda-benda lain. Okay, but to get the accuracy, to get the error rate, recall, precision, specificity, everything tu, you boleh derive daripada confusion matrix. Okay, now ini pun sama juga, you dah belajar dah dulu confusion matrix, sangat I think senang lah sebab you dah biasa kan. So in confusion matrix we have the actual class and also predicted class. Okay, so kalau actual class ni kita akan compare lah. Okay, actual class yang sepatutnya, tapi bila masuk dalam model kita keluarkan results apa. Is it true or the other class lah. So classifier's accuracy is to test whether how accurate your model predict class tu. Okay, untuk secara keseluruhan. So the accuracy punya Allahu Akbar. Dia punya formula adalah TP, the true positive, plus true negative, divide by total number of data that you have. TP plus TN plus FP plus FN. So sebenarnya bawah tu total number of data lah. Okay, error rate nak mudah, You tolak je 1 minus dengan accuracy tadi. Tapi kalau you nak kira formula dia FP plus FN. Meaning that false positive dan false negative dibahagikan dengan total number of data. That one is accuracy and also error rate. Okay, apa dia TP, apa TN, apa FP, apa FN, I think you already know about this. True positive is something yang macam you nak predict yes, then our model can predict yes too. Okay, maknanya dia correctly predicted lah. Okay, but true negative we predicted no and they don't have the disease. Ni dah contoh kalau kata dia ada disease lah. Okay, true negative. Kita predict sebagai no, tapi sebenarnya dia tak ada disease tu. False positive predict sebagai yes, but they don't actually have the disease. Okay, and false negative predicted no, and actually they do have the disease. Okay, and this is how to the formula lah untuk you calculate the positive rate, specificity, precision and prevalence. Okay, so accuracy here, TP plus TN divided by total. The total number of N that we have here is 165. So accuracy is 165. Accuracy adalah TN and TP kan. 100 plus dengan 50. So 150 divided by 165 kita dapat 0.91. So 0.91 kalau kita nak check percentage equivalent to 91% lah. So classification rate you boleh pakai formula atau you just minus 1 je lah. 1 minus the accuracy. So you will get 0.09 for the misclassification rate. For true positive rate, okay, true positive, you tengok kat situ, maknanya true positive, actual yes, predicted yes kan. So 100 over 105. Kenapa 105? Because kita nak tengok true positive rate tau. Maknanya yang mana number of actual yes yang you ada. Okay, so ini adalah dipanggil juga sebagai sensitivity ataupun sometimes people call it as a recall. Okay, and we have another one, false positive rate. Okay, yang mana dia kata apa? When it's actually no, how often it does it predict as yes. So kita akan ambil false positive. So false positive here, actual no tapi predicted yes. Okay, 10 bahagikan dengan 60 sebab total number of no. Okay, dia sepatutnya no tapi kita predict sebagai yes. So dia adalah 0.17, 1/6. Okay, and next one is specificity where it's actually no, but how often does it predict as no? So itu adalah true negative. Dia no dan kita predict dia sebagai no juga. So 50 divided by 60, the total number of no. Actual no total number of actual no, bukan predicted no. Ini pun selalu kadang-kadang students dia macam confused. Tak kata student, saya pun kadang-kadang miss jugalah bila nak buat skema tu kan. Okay. Specificity dah, precision. So how precise? Okay, we would like to see how precise the model predict yes. So maknanya TP divide by predicted. Okay, divide by 110 lah. Maknanya kita akan ambil TP 100 divide by the total number of predicted yes. So 100 bahagi 110 you akan dapat 0.91. Kan, prevalence, actual yes bahagi dengan total, actual yes you ada 105. Actual yes 105, maknanya total number of actual yes bahagikan dengan total number of samples that you have. Okay. So next. Okay, ini another notes. Ini saya ubah sikit daripada previous notes yang saya dah bagi dekat you all tu. Okay, kita tengok precision. Ini selalu naik dalam exam I think almost every semester. Cuma kita bagi different case study lah. Okay, precision. where precision is about positive predicted value. Okay, how precise kita punya model predict yes. Okay, so maknanya kat sini adalah ratio of correct positive prediction to the total predicted positive. Okay, so yang color merah, kotak merah tu, dia punya precision. So we would like to see how many of the positively classified were relevant for by our model. So a test can cheat and maximize this by only returning positive on one results it's most confident in. So tengok precision, TP divide by P. P is the total number of positive value yang you ada, divide by itu kita bahagikan TP lah, TP bahagi dengan P tadi. So TP divide by TP plus FP. Okay, tengok balik kat sini. Hai. Okay, TP bahagikan dengan TP plus FP. So you akan dapat precision. Okay, and then recall, also called as a sensitivity, ataupun for statistic they call it as a probability of detection or true positive rate. So it is actually a ratio of correct positive prediction to the total positive examples. And now for this recall ataupun sensitivity, we would like to see how good the test is at detecting the positive. Okay, so kalau tengok dua-dua images ni, dia sama. Recall and sensitivity tu, okay, menunjukkan benda yang sama. Kita nak tengok how apa kata the total positive divide by actual. Okay, so kalau kita patah balik kat sini, sensitivity kan, kita punya recall rate, so kita akan 100 divide by total actual. Okay, and specificity adalah the ratio of correct negative precision to the total negative examples. So dia akan tengok negatif punya ni lah. How good a test is avoiding the false alarm. Berapa banyak dia boleh predict sebagai no untuk cases yang no. So ni dia punya formula adalah TN divide by TN plus FP. Okay, kalau kat sini TN divide by TN plus FP. Maknanya dia akan tengok true negative kita divide by the total number of actual no. Okay, so itu adalah specificity. Next, okay, sensitivity and specificity. This one is very important if you have the imbalance problem. So I think most of you, okay, when you are doing FYP nanti, you will have the imbalance problem for your data set. Okay, ini memang common, sangat common. Sekarang ni lah, dulu-dulu dia nampak macam rare kan, ada a few cases sahaja yang ada imbalance ni, especially for fraud detection, medical data. But now if you are doing sentiment analysis, ataupun you nak buat customer segmentation, you nak buat customer profiling and everything tu, or classification pun sama juga, you akan dapat class imbalance. Okay, kalau you ambil daripada Kaggle, daripada yang the real data, you akan jumpalah benda ni, problem ni. Okay, the imbalance class. So even though dia kata kat situ one class may be rare, okay, for example fraud detection data kan, kalau kata nak cari fraudulent punya transaction tu very rare, very difficult. So let's say the proportion between fraud dengan legal punya transaction tu, let's say 90-10. So 10% je yang fraud. Jadi macam mana, how are you going to handle that? In statistics, there's a lot of methods. Okay, you boleh buat oversampling, you boleh buat undersampling untuk increase the number um, of the small group of class tu. Tapi kalau kata dalam data main dalam kita yang you all belajar dalam machine learning everything tu, mungkin you ambil je, tak apalah. Kalau kata imbalance pun imbalance lah, kan? Ambil je, tapi you need to be very careful lah. Maknanya you have the accuracy for that, tapi you also need to look at the sensitivity and specificity. Sebab kalau macam you pakai statistical method, you balancekan balik kelas tu, maybe you don't need this sensitivity and specificity. Okay, tapi balik pada machine learning, kalau you kata tak nak, kita nak pakai data apa yang kita ada, tak nak buat undersampling, tak nak buat oversampling, we just use whatever that we have, then you need to use this sensitivity and specificity to support you punya accuracy. Sometimes when you have the imbalanced class, your accuracy will be slightly low. Okay, tapi kalau kata you punya sensitivity tinggi, specificity tinggi, then most probably that particular model tu boleh diterima. Okay, and I have a notes here. Ini saya buat. So kalau you nampak conteng-conteng tu tepi tu, ni I think this note I buat waktu kelas machine learning. Tak ingat batch mana. Okay, bila melibatkan class imbalance, you kena buat stratified. Okay, bila you nak buat hold out method tu, ataupun you nak buat k-fold, you kena buat stratified sebenarnya. Sebab to make sure that both classes are balanced. Bukan balance je, balance dari segi distribution lah. Okay, if you have the balanced data set, so I think there will be no problem. Betul you check randomly, tapi bila random pun, kalau dia kata 50-50 dia punya balance, dia punya class balance tu, ataupun 60-10, you kena make sure that in training set, the portion untuk class A and class B tu mesti sama macam dengan original dataset. Okay, dalam original dataset kalau balance 50-50, so training set, even though you select it randomly, you kena make sure A ada 50, B pun ada 50%. Maknanya consist of dalam 80% tu, 40% dalam tu, 50% dalam 80% tu adalah A, another 50% belongs to B. Sama juga testing, 20%. 50% of the 20% must be A and another 50% belongs to B. That one balance Tapi kalau imbalance ni very crucial. You kena tengok betul-betul supaya you dapat results yang betul. Okay. Let's say imbalance dia punya imbalance dia adalah 70-30 ratio. Okay. 70 class A, 30 class B. So in training, let's say you buat hold out method, okay, training 80, testing 20. Dalam 80% tu, 70% of the 80% of your training data set tu must be class A and 30% of the 80% is class B. Okay, testing pun sama juga. So bila you buat macam tu, okay, you akan dapat elak bias. Kenapa saya kata dapat elak bias? Usually when you split it randomly, since itu adalah minority class, the majority class tu akan dominate everything. Okay, when you do classification, takut bila you buat random, tak buat stratified, yang 30% tu banyak masuk dekat dalam testing. Okay, so bila you test benda yang dia tak belajar, what will happen? Dia punya accuracy akan drop lah. Sebab dia tak boleh nak recognize. So in order to make sure that our model can learn data yang tu mesti sufficient untuk dia belajar tentang group B. So you need to make sure that you have apa kata, the same portion lah macam mana original tadi tu. Okay, itu penting. Okay, penting bila you buat hold out method. Sebab kadang-kadang students dia kata macam, oh tak madam, saya buat pakai default je. Saya buat random lah, 80, macam ikut dia lah ambil. Sebab dalam rapid minor kan dia macam you boleh auto saja kan. You boleh choose, ada drop down dekat situ, you boleh pilih stratified sampling. Okay, tolong ambil stratified sampling. Whatever condition pun you pakailah stratified sampling compared to random. Saya recommend lah, even though you have the balanced data set, tolonglah pakai stratified. Okay, so this is another example. Okay, cancer and not cancer. We have, okay, kita tengok kat sini, ada yes, no. Kalau kata sensitivity, specificity, precision, apa semua tu, you kena calculate lah. Maknanya you have the numbers here. For sensitivity, 90/300. Okay, the total number for sensitivity adalah okay 90. Kita predict sebagai yes, bahagikan dengan total number of yes. Specificity, okay, total number of no divide by, total number of predicted no divide by the total number of no yang you ada dekat dalam you punya data lah. Precision pun sama juga, 90 bahagi 230. Precision 90 over the total number of positive. Okay, positif yang dia dah predict lah. So recall 90/300. Okay, 90 bahagikan dengan total number of actual yes yang you ada. So you akan dapat the results here. And ini kita cerita balik tentang hold out method and cross validation. So hold out sama juga, you dah biasa dah benda tu, tolong tengok balik stratified yang saya dah cerita bebe tadi tu. And we have another one is cross validation. Okay, cross validation is the most popular question in ISP610 punya final exam. So cross validation of K-fold is where you need to partition the data into certain number of K. Okay, yang you kena bahagilah, tengoklah number of K you ada berapa and what is the best amount of K untuk you split. Okay, please make sure that every fold tu dia punya size equal. So at I iteration, use D as a test set and others as a training set. So let's say lah you bagi K sama dengan 10. Okay, so you will have 10 iteration. You akan buat dia 10 kali. Maknanya you run first round, the first set will be the testing, the other remaining 9 set as a training. So second round, second set akan jadi testing, yang lain akan jadi training. Third round, yang number 3 pula jadi testing, yang lain jadi training. Dan dia akan repeat sampai habislah. Okay, and then dia akan cari average. So leave one out, K4 where K equals to number of tuples for small size data, one sample is left out for testing. Okay, nampak tak kat situ? For small size data, if you have lots of data, you have enough data to train your model, you boleh pakai hold out method. But if you have a small number of data, let's say lah you ada 150 macam Iris tu kan, nak buat classification. 150 kalau you pakai hold out method, contoh kan 150 data, you nak buat split ratio 80/20. Okay, 80 bahagi dengan 80% out of 150 tadi, you akan dapat darab 150, 120. Okay, so 120 data untuk training, 30 data for testing. Tapi Cukup ke 120 tu untuk training? Cukup ke 30 ni tak ke banyak sangat since you have only 120 for training? Sebab you letak 20% of your data tu jadi testing kan. So bila you tak ada small data set ni, kalau boleh you opt for cross validation, k-fold. Sebab you treat every data tu equally. Okay, kalau data banyak 1,000, 2,000, 10,000, 100,000, tak kisah you nak pakai whole out method pun. Tapi kalau small, tolong choose for cross validation. Bila you ada large data set, contoh you ada 10,000, you nak pakai cross validation. Does it effective? Efficient ke tidak? Sebab you ada 10,000, you nak bagi jadi 10K for example, maknanya satu set, satu block tu akan ada 1,000. So 1,000 dia nak kena kira satu-satu mungkin dia akan melibatkan computation cost lah. It will require longer time untuk proses the k-fold untuk 10,000 data. Tapi kalau you pakai whole out method, dia lagi cepat. Okay, so dia ada pro and cons. You tengok the size of data that you have, try to relate with this one lah. Pilih yang mana satu bersesuaian dengan you. Dengan you punya case lah, bukan dengan you, dengan you punya data set. Okay, so kat sini you dah nampak in terms of training nak divide the data set satu, the performance evaluation another one. Maknanya setiap satu tu dalam you punya development daripada mula sampai habis semuanya penting, semuanya kena take into consideration, kena buat, kena ada justification. Kenapa you buat benda ni? Kenapa buat benda ni? Kenapa buat benda ni? Okay, you need to know how to answer that. Okay, the other one adalah nak cerita tentang ROC curve. Okay. So ROC curve stands for Receiver Operating Characteristics. So it's actually a visual representation lah, where you can compare using a graph. So this ROC curve originated from signal detection theory. Okay, dia akan tunjuk the trade-off between true positive and false positive rate. Okay, so dia kata the area under ROC curve is a measure of accuracy of the model. The rank the test tuple in decreasing order. The one that is most likely to belong to the positive class appears on the top of the list. So the closer to the diagonal line, okay, is less accurate is the model. The less accurate ni lah the model kan. Jom kita tengok. Okay, for example, we have two models here. Okay, model 1 and model 2. So, kita boleh assume kat sini yang model 1 is better than model 2. Sebab apa? Kalau you tengok dekat sini, y-axis is a true positive rate. Okay, so model 1 tu, dia punya value of true positive rate is higher than model 2. Okay, kalau you tengok kat sini, dia punya value dia lebih lah. Okay, and diagonal line ni, maknanya model tu ni dia dekat dengan diagonal line daripada model 1. Model 1 jauh. Jadi kita boleh kata model 1 is perform better than model 2. So vertical axis represent the true positive rate and horizontal false positive rate. Nampak model 2 dia lebih kepada false positive, tapi model 1 dia lebih kepada true positive lah. Sebab dia macam dia punya lengkung tu lagi besar kan. So the plot is also shows a diagonal line. The model with perfect accuracy will have the area of 1.0. Nampak 1.0. So area dia dekat 1.0 tu besar compared to model 2. Model 2 tu macam tak ada area langsung dekat 1.0. Okay. Okay. Ini adalah soalan yang I nak bagi you all buat. This is the real question untuk from previous semesters. For example, we have ni table 3 shows the actual and predicted number of glass type, glass data for glass data set, which are non-glass and glass, window glass lah. Okay, no window and window glass. So for window glass, we predict yes. For actual yes is 162 and predict no for window glass is 1. So based on this one, you need to calculate accuracy, misclassification rate. You need to also calculate the specificity and sensitivity. And last one, you need to elaborate. Okay, you need to discuss, you need to show how you can perform the stratified k-fold validation. Nampak tak? Ada word stratified dekat situ. So you kena mention what is stratified dalam k-fold validation. Waktu you explain macam mana you nak conduct the k-fold cross validation with k equals to 5. So tak kisahlah you nak pakai explanation yang macam mana pun, tak perlu ikut sebiji-sebiji dalam nota atau dalam buku. You can use your own words, you can sketch. Bila dia kata show how, you need to draw, you need to sketch how can we perform k-fold validation, cross validation for k equals to 5. So tunjuklah nanti akan ada 5 segments in your data set. So each of the segment tu kalau nak tunjuk stratified, you letak sikit lah, maknanya ini belongs to class ni, ini belongs to apa, for every segment tu. Okay, you need to do this. And we have another exercise. Okay, ini spam punya detection. So cross validation, you need to calculate accuracy, sama juga. Nampak? Soalannya adalah lebih kurang tapi casesnya lain. Okay. Yang E tu memang, I think Dr. Rohaila memang sukalah bagi soalan tu. Ini sebelum, tahun bila saya tak ingat. 2019, 2018 macam tu lah. 2018 saya rasa. Waktu awal-awal kita start this subject. Okay, so can you please do these two exercise? You all ada tak soalan ni? Dalam nota saya bagi hari tu dah ada kan? Hari ni saya tak ubah. Ni sama je. Except for this one yang dalam nota previous notes tu E tu dia tak nampak. Okay, what I can do is maybe I can snap benda ni bagi dekat dalam group lah. Pokoklah you rasa macam tak ada lah madam, tak apa, kita bagi dalam group. Sekejap saya baru bagi dekat group C, kejap lagi saya forward dekat group B dengan A. Okay, this one is the last slide. So do you have any question? Okay je kot, saya rasa sebab rapid minor pada cross validation confusion matrix ni you all dah belajar kan waktu data mining.
Saya lepas.
Oh, okay. Final apa? Data mining?
Saya tak ingat subjek apa tapi saya rasa data mining.
Data mining lah sebab dalam machine learning kita tak ada specific topic for confusion matrix. Kita cuma, we introduce to confusion matrix tapi sebab you all dah belajar dekat dalam data mining tu, jadi kita silentkan je lah dalam machine learning, assuming that data mining will cover for that section. Okay, tolong buat. Boleh?
Alright, Doktor.
Alright, so tolong buat ni. Nak soalan lagi saya boleh bagi saya cari kejap lagi saya post dekat dalam group a set of questions yang ada dalam EQPS. Tapi kalau ada soalan nak tanya boleh tanya bukannya saya macam tak ada soalan dan tak payahlah tanya. Tak boleh tanya. Kalau tak ada soalan, you boleh continue je buat benda tu.
Alright, Doktor.
Alright. So kalau you rasa macam nak leave the meeting, boleh, tak ada masalah. Kita offline pun tak apa. Tapi saya akan ada je lah dekat dalam Teams ni. Okay, so you can leave the meeting. Oh, lagi satu, jangan lupa tick you punya attendance dekat you future ya.
Doktor, saya ada soalan doktor.
Yes.
Regarding kelas B punya lab session. Minggu ni ada ke tak ada?
Minggu ni kan kita nak buat test hujung minggu.
Betul doktor, tapi kan sebab macam last week kan doktor tak ada. So macam
saya MC. Lah. Boleh sebab saya tak ajar you all rapid minor lagi kan. Tapi kalau rasa macam you all tak apalah, kita buat kelas je lah hari Rabu. Saya ada video, saya boleh bagi je video, boleh share je video yang saya buat dengan group C tu. Tapi kalau kata you all nak live class, boleh je, tak ada masalah. Saya
nanti saya boleh bincang dengan classmate doktor.
Nanti apa-apa you inform saya
Alright doktor, boleh.
Alright
doktor.
Doktor.
Yes.
Nak tanya slide tu boleh ambil kat mana?
Slide ni saya dah bagi kan? Tak ada Sekejap ya. Saya hantar dekat dalam. Saya rasa dah bagi benda ni. Dalam group. Sekejap dalam Teams ni saya rasa saya dah upload. Tak dia boleh banyak-banyak. Ni dia macam pening.
Doktor bagi yang chapter 2 je.
Oh saya tak bagi yang chapter 3. Sorry. Sekejap. Chapter 3. Okay. Sekejap saya nak forward dekat group lain. Group A dah dapat. Sekejap saya forward dekat group. Sorry lah. Allah. Kalau you tengok dalam You Future, ada juga. Tapi dalam You Future tu Dr. Rohaila punya slide dalam bentuk PDF. So saya suka pakai PowerPoint lagi sebab kadang-kadang ada benda kan nak kena tunjuk, nak kena sketch apa semua. So yang nota saya buat pakai PowerPoint ni ada a few things yang saya tambah. Okay, so you boleh dah ambil kat sana ataupun you boleh tengok juga yang saya punya ni sekali. Okay, dah dapat
Alright, thank you.
Alright, welcome. So cuba buat soalan tu.
Alright doktor.
Okay.